I'm going to show you how to use PyNIC. PyNIC it stands for Python based neutron interaction calculator. And so it is a program that's used by the University of Utah's nuclear reactor to measure and to kind of see what's going on inside the reactor core while experiments are placed inside the reactor core. So for some homework assignments, you might need PyNIC in some nuclear classes at the University of Utah. So here's a quick tutorial on how to use it. So after you downloaded the files, you're going to open up the files. And so mine's held in my nuclear folder, and you might be using version 1.02b. And you're just going to follow the same steps. You're just going to pick the GUI for what you're measuring, and it will most likely be neutrons. For this tutorial, I'm going to be using version 1.01b, which works just as well. So then I'm going to click it, then I'm going to click the GUI_NAA. And so GUI stands for, it's just a user face that you can have so that you can, you don't have to know Python to run this program. You just type in what's going on here. So first entry that we're going to fill out is a sample mass. And so you can change this to whatever sample mass that you are going to be using as you run an experiment. So you can use any mass at all. We're just going to leave it at 0.5 grams. That's fine. Then you have the irradiation time. This is the amount of time that you're going to have the experiment inside the nuclear reactor. And so it's common to use 5 minutes. A lot of my experiments I use 5 minutes. So we're going to leave that. You might have a different amount of time. It depends on the half-life and the elements in the nuclide that you're irradiating as well. Then you have the decay time. This is the time that you have the sample in the nuclear reactor, but you're not counting it quite yet. So this is just the time for the interactions and the radiation to decay before you're going to start calculating it. And then the multiplication factor, just leave that alone. We don't need to deal with that at all. And then this irradiation port. We have different irradiation ports inside the nuclear reactor, the TRIGA reactor at the University of Utah. There's a few different ports. Right now we have simulations and we have measurements for the FNIF, the TI, and the CI at these power levels. We will be adding more as well. So if yours has a little bit more, you just have a newer version of PyNIC. So we're just going to be using 30 kilowatts of the TI. That sounds good. And then you're going to pick your nuclides. So you can add up to 10 nuclides that you're going to be measuring from your sample. So up to 10 elements that you're kind of want to see what's going on as they interact in the nuclear reactor. And so a common experiment that you'll be doing is going to be with nickel-64, especially in the nuclear classes. So I'm going to select nickel-64, and this percent mass abundance in sample just means how much of the nickel sample, the pure nickel sample you have, is actually nickel-64, because there's different nuclides of nickel. So to get to this, you're going to go to atom.carry.re.kr, as you see up here, and it's going to bring you to this page. You're going to press Table of Nuclides, and then up on the nuclide name, you're going to type in what nuclide you're looking for. So we're looking for nickel, Ni, nickel-64, and then perfect, it gives us the percentage right here. So this means in a sample of 100% nickel, 68% of it is nickel-58, and then 0.09% of it is nickel-64. And so we're going to go back to PyNIC. We're going to paste that in. So we have our percent mass abundance in sample is 0.925%. And so the percent mass abundance does not have to be 100%, as you can see, and you do not need to fill out the rest of these. In fact, you should leave them as zeros if you're not going to be doing additional nuclides. But if you are going to be doing additional nuclides, you can just select it and look up the percent mass abundance and put it in. And then you're going to leave these two entries alone, and you can just press the Perform Calculations button. And then this Perform Calculations button will perform the calculations through PyNIC, and then it's going to export them on a text file for you to read. In the text file, you will find in the same folder where your version of PyNIC is in the NAA report. So you go to NAA, and then as you can see, our sample was 0.5 grams, if you remember, in 5 minutes was our irradiation time. Our decay time is 1, and we selected 30 kilowatts in the thermo irradiator. That's what TI stands for. And so here's our output of information. So it says the nuclide half. So when when nickel 64 went in the nuclear reactor, it interacted and it became nickel 65. And nickel 65, so it's giving us the information for nickel 65 now, because that's what it turned into. So you see the activity in millicuries is in this column. Then you have the activity per gram. And then you have the half-life in minutes. So you can kind of estimate how long it will take for this to become safe if it's not safe already. So then you go down to table 2, you have the calculated dose rate, and this is really helpful. So this lets us know if the sample that you are irradiating in the nuclear reactor, if it's safe to take out. And as you can see, our experiment, if we were to actually have done this experiment of putting half a gram of nickel into the nuclear reactor at 30 kilowatts, the dose rate that would come after 1 minute of decay time is 0.01 milligram per hour. So that's very safe. So that means we can take it out of the nuclear reactor and not worry about getting any radiation doses that might be a little bit too high. And then if you keep going down, it'll give you specific gamma energies. And these gamma energies you'll use when you start using the high purity germanium detector. They'll come in handy there. And then it just gives you a little bit more information, but the main thing that we want to look at is just this dose rate to make sure that it's safe to take the nickel out of the reactor, and it is. So that is just a quick tutorial on how to use PyNIC. And if you have any questions, feel free to ask or email me. I'll have my email down in the information section.